Thank you, members, all of those who are online participating. Thank you, the organizers, for inviting me to make this presentation. The title is Transforming Farming Systems in Sub-Saharan Africa Using AI, Enhancing Productivity and Sustainability for Smallholder farmers. This directly contributes to Sustainable Development Goal number 2 of reducing hunger. My name is Moses Tenywa. I'm the director of an upcoming university called Light Open and Blended University. And my co-author is Samuel Mwesiba, who has just completed this degree in electrical engineering in Mbara University, Science and Technology. The outline of my presentation is as follows. I'm going to give an introduction, then the problem we are trying to address, the historical context of what has so far been done, and the gap, then the role of AI in agriculture, how AI helps in data collection, how it helps in data analysis, and the statistical tests for the relationships, challenges, future outlook, and conclusions. In Africa, especially Sub-Saharan Africa, the majority of the population depend on agriculture. According to Michael Lipton, no country has achieved poverty reduction without significant investment or success in agriculture. That means if Africa is to transform, then we must really make sure that our agriculture is successful, it is on top, which has not yet happened. We have demographic pressure, the population is growing, and a large number of the poor households participate in agriculture as a way of addressing poverty, but there is very limited success in that direction. Evidence from econometric analysis indicates that agriculture can be very helpful in addressing poverty or improving livelihoods for the very poor people, whereas the non-agriculture sector can help those who are a little bit well-resourced. So, what are the constraints we have? Over the years, in spite of the efforts in research by the development agents, we have continued to register persistently low and declining yields in our farming. And the constraints are partly due to the highly weathered old soils. Our soils, many people, like if you come to Uganda, you would see the green. But the fact is that the soils are extremely weathered and the inherent nutrients are generally low. So they require some better management. In some cases, we have even acidity, so you may apply fertilizers, but if you don't take care of the acidity of the soil, then you have suboptimal performance in terms of response to the fertilizers. Then, because of the demographic pressure, there has been continuous cultivation, mining the soils and making them further degraded. Because of the good weather, pests and diseases are many, and climate change has escalated them. We also have climate change risks from extreme events like droughts, floods, and heat waves, which are also common, and land degradation generally associated with the continuous cultivation. And few people have adopted improved methods of production for several factors, including poverty. So what's the problem? The problem of low productivity is intertwined with land degradation, and plant condition, and the environment. The low productivity is largely attributed to the suboptimal management resulting from limited data, which could help in understanding the complex soil, plant, and atmosphere nexus, which is overlying highly heterogeneous soils. We have hills and valleys, so even if you have research from the research institution through the extension workers to support the farmers within one acreage, you would find differences. So extension becomes ineffective because of the complexity and the highly heterogeneous soils and environment. This has been accentuated by the negative impacts of climate change due to floods, droughts, and heat waves. The decision making, because of the complexity and limited data, limited research, based on insufficient information of the plant and farming systems. I will not go so much into this slide, but this one gives the drivers, the pressures, the impacts, the state, and the current responses. But they are all generally leading to a degradation poverty cycle complexity. So what has so far been done in the past? Have in the next slide, quadrant 1, which is here. In this quadrant, I depict the traditional farming methods before modernization, which was basically relying on traditional knowledge. But because of the population growth, population pressure, it could no longer support food production. So then the science came in this quadrant 2, where we have intensification based on the Green Revolution, where there was the application of external inputs, mechanization, use of agrochemicals, better seeds, breeds, and all of that. Initially, this was promising, but over the time, because of limited information, it couldn't solve the problems of hunger in Sub-Saharan Africa, because the organic matter declined as a result of application of external inputs. So realizing that organic matter is important for longer term or for sustainable agricultural production, most of the science now shifted, and this is where most of our work is in quadrant number 3. This is where most of the experts are trying to combine indigenous knowledge, scientific knowledge, organic and inorganic, using the integrated soil fertility management framework. However, this has also not helped the problems. So in our work, it's more of pioneering work. We want to now take some of the lessons from quadrant 3 and we leapfrog and transform the agriculture in Sub-Saharan Africa in this quadrant number 4 of the fourth industrial revolution, where we want to collect some data, intensive data or big data, and then do the training through algorithms, machine learning, and then we would be able to address the problems. So what's the value proposition? Our value proposition is that data-driven plant growth management would be the one that would lead to optimal functionality and sustainability. And this involvement of advanced machine learning algorithms and training on plant-based processes, provision of real-time analysis of soil, crop, and weather data to inform decision-making in agricultural practices such as planting, fertilization, watering, weed control, spraying pesticides, and harvesting. The technological components, data capture and analysis. AI plays a significant role in the collection of soil crop and atmospheric data from machine learning, real-time monitoring for precision farming. That's on a bigger area. We will initially focus on single plants and collect big data then, but we move on to precision farming over bigger area. Provision of real-time information for implementation of precision farming practices. Spatial temporal data. AI plays a big role in capturing and visualizing soil and information for precision farming. It's a powerful tool for data analysis, recognizing trends, patterns for better decision making. And this would lead to increased productivity and profitability for sustainability, which is our major goal. So increased productivity and profitability is envisaged to result from AI data-driven precision interventions tailored to plant-specific nutritional and water requirements. Targeted use of resources results in savings and increased profitability. So, the meat of my presentation, how AI helps in data collection. Use of sensors and data collection. For moisture, we monitor water content in the soil, which is essential for determining irrigation needs or water use. Then, as I mentioned earlier, that many farmers in Sub-Saharan Africa have been applying fertilizers, but because of poor management of the acidity or alkalinity of the soil, which influences the nutrient availability, they have not registered the desired responses. So we shall also be monitoring that using AI. Nutrient content, tracking essential elements like nitrogen, phosphorus, and potassium. These are the major ones, the macro ones, but we can, once we have understood this better through AI, we can then also move on to the micro elements. Atmospheric temperature and relative humidity are also critical. We hope to have sensors monitoring those ones. Then the analysis of the data. Data processing. Machine learning algorithms. These algorithms process the data collected from the sensors to identify patterns and trends over time. Then real-time monitoring. AI enables continuous monitoring of soil conditions for farmers. Data integration. AI systems integrate soil data with weather forecasts, crop types, growth stage to provide tailored recommendations for precision farming. How we shall do it? We shall split the data. Initially, we have the crop yields, but we will begin by training the X so that we target, for example, fertilizer rates. We do the training of what we call the futures. Future parameters include soil nutrients, soil pH, and all of those moisture, which affect the fertilizer rates. So the fertilizer rates is what we call the target. Then the others are the futures. So the target, which is fertilizer, we can do the training, AI-based training for soil pH, soil nutrient, and soil moisture to determine the fertilizers. Y train, that is the target. Then X train is the futures, the factors that control fertilizer rates. Then we do the aggregation where now the target is the yield. This one is broader because this one now, besides the soil, we include the temperature, relative humidity, and all of that for the yield targets. The way we shall do it is to move from the training by basically collecting data for the futures like pH and all of that, and then around this centroid get the best fitting for it, AI-based fitting, which can now help to determine how, for example, pH or soil moisture is affecting fertilizer rates. Then once we have trained for the different futures, we can then move to the full prediction of the yields, which is why using the various factors. Then we shall do the assessment of the strengths of the relationships between the target and the future, using the multiple regression coefficients, which indicates the change in magnitude and direction of the train variable vis-a-vis, for example, if one unit change in futures affects the target variable. Then we shall do the R-squared, a statistic that measures the proportion of variance in the train variables as explained by the future variables. The higher the value, the stronger the relationship. Similar to that is the adjusted R-square, which gives a more or a better estimate with the corrections. Then we shall also do the F statistics, which is used to test whether at least one of the regression coefficients is different. And that means if it is not zero, it indicates a relationship between Y target and the X futures. Then the p-values will be used to determine the significance of individual regression coefficients. If we have a probability of less than 0.005, indicates a prediction with over 95% confidence. Then we shall have the standard coefficients to monitor the sensitivity of the independent variables affecting our yields. Then we shall also do a variation inflation factor, which is used to detect the multicollinearity between the future factors, the independent variables. We don't want them to be correlated. We want them to be independently affecting the yields. Then I will also help us to do the residual analysis, which is helpful in assessing the model fit, evaluating the residues between the observed and predicted values. User-friendly technology. Accessibility for farmers. We shall be able to develop apps for farmers where they can now be able to take benefit of the algorithms, which will be user-friendly and simple to use in a mobile app interface, which we envisage will result in better yields. Improved yields and livelihood. Data-driven decision-making will inform sustainable practices. Sustainable practices will result in improved yields. Improved yields will result in increased returns and income for farmers. Increased income will result in reduced poverty and improved livelihoods for the communities. So in the process, we hope we can transform finally the smallholder farming systems in Sub-Saharan Africa. Some of the challenges, like I was talking to Anne, is the power outages. We often get power outages, some due to drought. There's also limited access to digital phones. A large majority, especially the women who farm, they still have analog phones. And there's also low digital literacy, poor infrastructure, as I've mentioned, internet connectivity issues. Future outlook, scaling and expansion. We hope once we have generated sufficient information, we may change institutions, we may lobby and advocate for strategic policies that can create an enabling environment. Like many of the past speakers have mentioned, that there is a need for significant investment in AI, in education, in the infrastructure, and all of this. I think many of those are common cross-cutting issues that can be captured for scaling and expansion. Increased knowledge and understanding of the potential of AI in agriculture in the Sub-Saharan Africa economies will unlock opportunities for broader implementation, job creation, because then once we have the agriculture vibrant, this can lead to agro industries and finally the other industries using even the investments or the returns in agriculture to invest in other industries, minerals, and all of that. Sensitization and building partnerships with local governments and NGOs will foster greater support and use of AI for sustainable development. In conclusion, AI has tremendous transformative potential for Sub-Saharan Africa data-driven farming, which is yet to be unlocked. AI is useful in collection of complex data sets with high spatial and temporal variability. AI is useful in analysis of diverse data sets to inform decision-making. Big data collected from complex soil, plant, atmosphere nexus can be used for AI machine learning and training for sustainability, increased productivity, and improved livelihoods. There is need for multi-stakeholder involvement, especially policymakers, to create an enabling environment for AI through understanding its transformative power for smallholder farming systems. I want to thank the organizers of the second Global Summit on Artificial Intelligence for kindly allowing me and my colleague to make this presentation. Specific appreciation go to Anne for the excellent organization. Thank you all for listening globally. God bless you.
Thank you so much for your presentation, Professor Moses. Delegates, do you have any queries regarding the presentation?
I will, maybe you could use the one that you have, or I can work out a link and share. What do you prefer?
Sorry? I'd like to
Will
share
you
your
share
email
what
ID.
you have, or I have to be the one to send?
I'd like to share your email ID. We have
Okay.
a PPT presentation. Thank you so much for attending. Have a nice day.
Thank you.